Hello, welcome to Block 3, Equality and Equivalence, Lesson 1. I'll share my screen. For Lesson 1, you're going to learn how to work with the meaning of equality. So you will understand the meaning of equality and how to use these facts to answer some questions. But before we start, I would like you to do the retrieval practice. So the starter, the way some of you call it. So I'd like you to do retrieval practice. So you can pause the video and answer the questions in 3 minutes. Or you can take longer. You can even do it in 4 minutes. All right. Assuming you have paused the video and you have worked through the questions, really taking your time to think through, here are the answers. Okay, so for question 1, you were asked to fill in the missing numbers in the calculation. All right, so these are calculations you could have done. There are different ways you would have done this using knowledge that you learned in primary school or in SATs or in any other class. So depending on what year you are taking this lesson. Okay, I'm sure you may have used the facts from this first question to answer this one. Okay, we're going to revisit it in this lesson. And then the bar model, you were told to work out the total value of the bar model. Remember, in our earlier lessons, we said we always add the bars in the bar model. Okay, so 16 add 4 is 20, 20 add 9 is 29. Okay, so this is what we did. Okay, and then work out the total value of the bar model. All right, you could just add 4 add 4 add 4, or you could do 3 lots of 4. Okay, so you should remember this if you've taken if you've gone through our lessons in algebra. So block 2, you should have come across this. Okay, all right, let's do some new learning. Okay, how would you say this calculation? I want you to have a think. Right, some may say this calculation as 4 add 11 is 4 add 7 is 11. Someone else might say 4 add 7 makes 11. And then another person might say 4 add 7 equal to 11. Notice that the mathematical symbols add and equal is used in this statement. So I tend to favor that one. You would see why when we look at the next example. Now imagine you want to say this by saying 15 is 7 add 8. Doesn't really sound quite right, does it? What about this? 15 makes 7 add 8. 15 doesn't make 7 add 8. What is it making? Is it making pot noodles or what? So the correct way to say it is 15 is equal to 7 add 8. Right? So we're using the correct mathematical words and we're using expressing the symbols that are actually there in the calculation. 15 is equal to 7 add 8. All right. What about this one? Would we do this calculation? Are they actually equal? Remember, this sign equal, you should have learned this in primary school or some other time, means what's on the left is actually equal to what's on the right. So let's check. How would we say this calculation? We would say 12 add 3 is equal to 21 subtract 6. So you can see we've actually used the right words to express all the mathematical symbols that are in the calculation. We've used add, we've used equal, and we've used subtract. Okay, and we've actually mentioned the numbers in the calculation. So these are correct ways of expressing equality. Remember, the title of our lesson is Understand the meaning of equality. Okay, so I would like you to have a go at question 1 and 2. Having had a brief learning of how to read equality, how to read calculations properly. Okay, assuming you have paused the video and worked through these questions. So here are the questions. Yeah, assuming you've paused it and you've answered the question, you can take about 4 minutes to do this. Here are the answers. Let's look at them. Okay, so for question 1, you were asked which calculations are correct. So it's about thinking about your numbers really carefully. All right. And then for question 2, it's the same thing. You're being asked which calculations are correct. It's about thinking about your numbers, use of the numbers, and you can even use your calculator to check it. But I encourage doing calculations mentally to really strengthen your mental calculation strength or muscle, I would say. So here are the answers. Okay. If you look at this bar model, did you remember in our previous lessons how we work with bar models? Right? We simply add them. So what calculations can you spot? How many calculations can you actually spot in this bar model? Well, we can see this one. So if we look at the whole lot, we can say, well, 15 add 15 is equal to 15, 5 add 5, 5 add 5, add 5, add 5, add 5, which is actually, if you remember our previous lesson, we can also, if we look at the left side, if we say, okay, let's just look at the left side of this bar model, 15 is same thing as 5 lots of 3, right? It's 5 lots of 3, or we could have said 5 add 5 add 5. But what about if we have something like this? We can say, well, 15 is equal to, so 15 subtract 5. So imagine this is crossed out. So 15, this means 15 subtract 5 is same thing as 5, 2 lots of 5, which is 5 times 2. Okay. So it's important, especially this one, you really think about what is going on here because we're going to use it, in this lesson. Okay. So look at what we've done. This bar model, the way it's represented, is represented by this calculation. So 15 subtract 5 is equal to 2 lots of 5, 5 times 2. Okay, what we've done so far is we've looked at how you can use a bar model to represent really simple calculation because it's helping you to really think about what's going on how to break a calculation down and really understand how to solve problems. You would see how useful it is when in our next lesson. So lesson 2. Okay, I would like you to pause the video and have a go at questions 3 and 4. You can do them in about 4 minutes if you choose to, or even less than that. Okay, assuming you pause the video and you've really thought about these questions, you've worked through them, here are the answers. Let's discuss them. So question 3, you were asked, draw a bar model to show that 50 plus 30 is equal to 80. Okay, remember our bar model, we add. Okay, we add. So we're going to have 2 bars. one being 50 and the other 30, and then we're going to have 80 as a big bar. And then question 4, you ask, how many equations can you write using this number wall? Okay, 2 have been done for you. So we can do lots of calculations. You can see here 6 lots of 5. So 6 lots of 5, this whole lot at the top, is equal to 3 lots of 10. And 3 times 5, so 3 lots of 5, which is this one here, is equal to 9 add 4, add 2. So 9 add 4, add 2. So this here is the same thing. You can see it's half, right? It's half of the whole lot. So if this is half of that, so they must be equal to each other. Yeah? So there are different calculations we can spot from the bar model. So, but here is an example. So for example, 3 times 5 is equal to that. So 3 times 5, so this bit here is equal to this here because they are of the same size when you look at the whole lot. And then we can also spot this one. 3 times 10 is equal to 25 add 5. So 3 times 10, so 3 lots of these is the same thing as this one. Yeah. Okay, really interesting. Okay. Now, what if we have a calculation like this where we have missing values? What could we do? How could we find the answers to the missing values? It's about thinking about the calculation. We can use bar model to start mentally thinking about what's going on. So 4 lots of 5, we can draw it like this. Now, if it's equal to 12 add something we don't know, we can draw a bar model underneath to add right 12, and then with a bar that is missing, we don't know what's in there. But don't forget that 25, 4 lots of that 5 is 20. So we can actually say, okay, if we rewrite this, it means 20 is equal to 12 add something we don't know. So another way to get what's missing, you can simply say, okay, I know the bar model, if I add these, I will get 20. So if I take this from 20, then I will get 8, right? Okay, what about this one? Did you remember when you did your retrieval practice, there was this question that looked like this, yeah? So this question, here we have 8 add 15 is equal to 23. How can we, the question is, I want you to think, how can we use these facts, this calculation to help us do this one on the right? Yeah, we know that this should be, if this is 23, we can use the knowledge of knowing that, okay, 8 add 15 is 23. Okay, so we can use that knowledge to answer this because we know that this is already equal to 23. Now, notice that this one, notice that the 8 is one lot more than this. Yeah, so if 8 add 15 is 23, and in this other calculation where we're trying to find a missing value, is also equal to 23. So we can make both of them equal to each other. So if this one is one lot less than this, what does that tell you? Yeah, if this is one less than 8, could this be to compensate for it because it has to be equal? What do you think? That's 1 less than 8. That has to be 1 more than 15. I want you to really think about using equality, how we have solved this problem. So we know about this. We relate this to that and say, okay, if this is 1 less than that, and then if I'm adding that to get 23 and they're equal, that has to be 1 more than this one. Let's look at another one. So look at this calculation. 280 minus a number we don't know is equal to 28 times 9. Now I want you to think carefully. What do you notice? What's the relationship between 280 and 28? Well, if we draw as a bar model, if we draw it, we'll see that 280 is 10 lots of 28. 10 lots of 28, right? 10 lots of 28. But notice that on the right hand side, we're only doing 28 times 9, right? So you're thinking, hang on, but 280 is 10 lots of 28. So if we're doing 28 times 9, it means we're only using 9 lots of 28. So where's that 28 gone? Of course, we can represent that as when we cross something out from a bar model, we can represent it as subtraction. So you should not be surprised to see that what's missing is 28. Yeah? So it's really good. What we're learning so far is really good. You start to use your bar model to really think about, okay, how do I relate things that I already know, the facts that I already know, and use it to help me in a calculation if I know that they are equal. Okay, I want you to pause the video and have a go at, because you're going to be answering the rest of the questions, have a go at questions 5 to 7. You can pause the video and do questions 5 to 7 in 5 or 6 minutes. Okay, now assuming you've paused the video, you've really worked through this and you've enjoyed working through it. So here are the answers. So these are the answers for question 5 to 7. So these are just calculations you were asked to do. So for question 5, you were asked to work out complete the equations. Okay. So yeah, so remember using those facts we know of. So 9 add 6, you're checking what's missing to get the calculation complete. All right. So this really helps you think about how we use equality facts to help us do calculations really quickly. So for example, for question 5A, okay, you can see the missing value is 10. Yeah. So let's talk about how you can use equality facts. All right. So you can see here, this one is 9 add 6. Right. So if 9 add 6, you can see this 5 is 1 less than 6. So you don't even need to do, try to do, I need to add first, then subtract 5. You can just use this equality fact to say, okay, if this is 1 less, then that has to be 1 more. So that should be 10. Straight away, you just spot it. Okay. So these are some really cool way to do calculations really quickly. Very efficient way to do calculations like this. Okay. All right. And let's just display the answers for you to mark. And I want you to really think about the answers and how those equality property is used to answer these questions. Okay, here is question 8 and 9. Pause the video and do it in 4 minutes. Okay, so assuming you have paused the video and you've really worked through these questions, here are the answers. So remember Jack's method. So let me take you back for question 8 and 9. Yeah. For question 8, let's talk about what Jack's method was about. So Jack's method is this one here. So Jack was saying that to do this calculation, he's finding the missing number in the equation. And Jack said 326 is 1 more than 325. So to maintain equality for missing number, for the missing number must be one less than this. Okay. So they're telling you to use that same method to answer. So of course Jack is correct because this is the same. So if this, yeah, calculation, you see the answer there. So 326, which is one more. All right. So that's going to be, so this can be written like this. Yeah. So this becomes 4390. Yeah. Because remember it was 326. So that has to be one less than that one. Okay. So they're asking you to use the method to answer this. All right. You can see here 7820. You can see that it is 3 less than this one. So you should be thinking, okay, it means whatever I write here relative to this one has to be 3 more here. Okay? Because this is 3 less. So you compensate for it there. Okay, so here are the answers. So you can see it's 339 for 8A, which is 3 less. You can see it there. Okay, because this is 3 more than that one. So you need to compensate on this side. So it's going to be 3 less compared to that. So 3 less will have to be 3. Yeah, you can see the answer there. Where is it? Question 8 and 9. Sorry. 339. Yeah, you can see it there. So really, really interesting way to handle calculation. And it's the same for B. So you can see this one is 29410. Yeah, 29410. Let's do some writing. So you can see this is 29410. This is 29403. So this is 7 less than this. This is 7 less than this. Okay. So if this is 7 less compared to that, then you need to compensate for the 7 here. So you need to have 7 more of this. 7 more of this. So check the answer. You'll see here. So 785. You see that? At 7. Yeah. So this answer here came from 785 at 7. Yeah. 5 at 7 is 12. 2 carry 1. You write 9 and then that's 7. Okay. So it's a very clever way to do calculations when you understand this principle of equality. So if you know this, when you compare it to somebody who doesn't know how to use this equality fact, the person will add them and then start trying to subtract. No, you don't need to do that. You need to use an efficient method, which we've learned in this lesson, which is using equality facts. And it's the same. Yeah. So does the same method work when subtraction is involved? Investigate by finding the missing numbers in the equations. Okay. So that is for C. Yeah, you can see 2373. Yeah, that's one. See, that's one less compared to that. If it's going to work, we need to compensate. You see, this is one more than this. So we need to compensate by making this. Yeah, you see the calculation. One more. So when you go, you see that 2373. This one is 2372. Yeah. So because it's, yeah, so you need to compensate for that here because this is one less. So you need to make this one more. Yeah. Okay. So this is the end of our lesson. So what we've learned so far is using equality and understanding that with equality you can use, equivalence. You can say, okay, I know this calculation is equal to the other calculation. So if this one is one less, then on the other side of the calculation, I can make it one more to make sure I get the equality in calculation. All right. Okay. Until next time, take care and bye bye.